So let us solve another problem. Finding the greatest common divisor using Euclid's algorithm. Okay. First is we are going to understand what is a problem. Second is we are going to see why I need to use a recursion. If I use a recursion, what is a base component? What is a recursive component? Okay, this is what we are going to see. So the same, let's take two numbers, okay, x and y. Let's say in this case my x is, I'm taking the same, x is what 125, y is what 175. I want to find the greatest common divisor. We solved using Dijkstra's algorithm. Now I'm going to teach you what is Euclid's algorithm and how a recursion will help you to solve the problem. So I have been given two numbers, x and y. So what does the algorithm says? The algorithm says like this. First is find the remainder. Divide the first number by the second number and find the remainder. What is the first number? 125. What is the second number? 175. If I divide 125 by 175, what I'm going to get? I'm going to get the quotient is 0. If the quotient is 0, my x becomes a remainder. Remember. Now, if the remainder is not 0, what the algorithm says is, if the remainder is not 0, make the y as x and remainder as y. Make the y as x and remainder as what? Y. Now, divide again 175 by 125. What is the quotient? Quotient is 1. Because when I divide 175 by 125, 125 is there in 175. What is the remainder? Remainder is 50. If the remainder is not 0, make the y as x and remainder as y. So if I do like this, what happened? 125 divided by 50. The quotient is 2 and the remainder is 25. 2 50s are 100. Remainder is what? 25. If the remainder is not 0, what I should do? Make the y as x and remainder as y. So 50 divided by 25, how much I get what? Quotient is 2, the remainder is 0. If the remainder is 0, y will become the greatest common divisor. Now, that means here, when I should stop the procedure is, when I find the remainder is 0. If the remainder is 0, the y becomes a GCD. Okay. Can I say the GCD of 50 and 25 is 25? The GCD of 125 and 50 is also 25 only. The GCD of 175 and 125 is also what? 25 only. The GCD of 125 and 175 is also what? 25. Correct? That means if you ask me what is a GCD of 175 and 125 is, I am going to say the GCD of 175 and 125 is same as the GCD of 125 and 50. How did I get the 125? I brought the y in the place of x and remainder in the place of y. If you ask me what is the GCD of 125 and 50s, I can say the GCD of 125 and 50 is same as the GCD of 50 and what? 25. Therefore, here I am solving a problem using the problem itself. What is the problem? This was given to me. What I am giving a solution? I am giving another solution to find the GCD of 175 and 125. Right? Therefore, I am able to solve this problem using recursion. Now, what is a base component? When I should stop the recursion? When I find the remainder is 0. If I don't find it, what I should do? I need to interchange the position of y to x, remainder to what? Y. This is what I need to do and find the GCD of the same. Correct? Okay. Therefore, now simply you can say my base component is, if x and y are two numbers, GCD is my function, is going to find the GCD of two numbers, integer x and y, integer. If what? If x mod y is 0. How do you find the remainder? If the x mod y is 0, what I should do? Who is a GCD? I can directly return. What I can directly return? What? Y. Right? Base component need to directly return value. Otherwise, the GCD of 175 and 125 is same as the GCD of 125 and 50. Therefore, how do I write it? In this case, integer z is equal to GCD of what becomes the y came in the place of x and the remainder came in the place of y. That result needs to be returned. Yeah. So let us see as a code, then we will come back how it is working. I'm going to show you. Okay. So let us see. I'm going to write if x is what? 125, y is 175. Any number you take, was I take it, easy for me to calculate. Okay. So integer z is equal. I'm going to find the GCD of these two. Therefore, I'm going to call the function GCD x comma y. It's going to give me a result. I need to print it. Percentage d comma what z. Right. So I'm going to call my GCD. GCD in bracket integer x comma integer y. You have studied function. I know the variable name is not necessary x and y has to be same. Okay, they are two different ones. What we said the base component, when I should stop the recursion, if I find the remainder is 0, what I should return the y. If not, what? If not, integer z is equal to what I should return to him. I need to find the GCD of y comes in the place of x and the remainder comes in the place of y. That's it. I'm going to return z. Right? I call the function. I'm going to run it. I got the answer what? 25. I got the answer what? 25. Got it. Okay. If you put some other number, I should get it 185 and 225. Any number you can use. I can get the value 5. 5 is the GCD. Okay. Let us see here how the answer came. Okay. So I'm going to go back to this board and I'm going to explain to you. So this was our code was. Okay. Let us see here in this case. I passed from the main 125 and 175. Okay, passed. So how the answer is getting derived, let us see. So I call the function from the main is a caller. What is the parameters I passed? What? 125 and 175. Now some might wonder that the first number has to be greater than second number. No, because if the first number is not greater than the second, see here it automatically rotates. It brings a greater number to the first position, smaller number to the second position. Therefore, you don't need to worry about it. Okay. Now, what we said, if m is what main is a caller, main function is called with this value. Now I call this function x mod y is equal to 0. No, because 125 modulus 175 is not 0. Therefore, what I need to do, I need to execute two statements. The first statement is this. What is the first statement? GCD of 175 and x mod y is how much? What? 125. I called again. When I called again, 175 modulus 125 is 50. 50 is not 0. Two statements. First statement. What is the first statement? GCD of y. Y is how much? What? 125. X mod y is how much? It is what? 50. 175. I call again. When I call again, x is how much? What? 125. Y is what? 50. 125 modulus 50. How much it is? What? 25. 25 is not 0. Therefore, I need to execute two statements. First statement, I call the function for 50 and what? 25. Correct? I call the function for 50 and 25. When I call for 50 and 25, 50 modulus 25, how much I get? What? 0. 0 means only one statement. What is the one statement? Y needs to be returned. Y means how much? What? 25. Where the return will go? Back to the caller. Where it gets stored? In Z. Now, return 25. This 25 will return to where? To the caller. Now I say next is what? 25 return. Where will go? Back to the caller. It stores in C. Return 25. Whom will return to the main? Okay, this is the way it worked for you.